Hey, what's up? I'm going to show you guys how to use math type, and I'm also going to go over a test right now. I'm going to be going over a test on finance, so compound interest, annuities, amortization, simple interest. So let's start. So here it says Carmen invests $9,000 in a retirement fund that pays 5.4% compounded interest. Alright, so I go to math type right here. I like doing inline. I click that, and I'm going to start entering the solution. So compare the value of the fund after 20 years if the interest is simple interest. Let's see, simple interest has the formula. What are we looking for? The value of the fund, we're looking for a future value. A equals P times 1 plus RT, right? That's simple interest, which in this case is going to be, what's 9,000 times 1 plus R, which is 0.054 times, what's T, 20 years. Alright, so that's how we plug that in. So whatever that is, we won't really find the answer. I think I need to get the answers right now. So let me pull up Google or something to get the answers. You guys can get the answers on a calculator easily. Just plugging it in, 9,000. Let's see if this, how am I going to plug this in? Let me go to something like Desmos, maybe. What would be a good calculator? Let's try something like this. Do I want a graphing calculator, or do I want a scientific? Let's try this out. It's going to get more complicated later, but 1 plus 0.0554 times 20, 18,720. Alright, 18,720. There's your answer. When you finish, you're just going to press the X button and it will throw it in there for you. There you go. Alright, our B says compare the value of the fund after 20 years if the interest is compounded quarterly. So for on this one, I'm going to go to math type. I'm going to put inline, and then I'm going to, what are we doing? Quarterly compound interest here, so we got a different formula, so we could say A equals to P1, what is it, 1 plus I, and we need an exponent. We can throw in an exponent of N, and we'll say that this is equal to 9,000. We'll throw in 1 plus, now the periodic interest rate is going to be a fraction, so fractions are right here. Click that, throw in 0.054, and then divide it by, quarterly, we'll divide it by 4. Go over here, and I don't like how that looks. Let's see if I can do something better. If I put this in here, it may look better. So 1 plus, see if it helps it. Yep, see how the parentheses got bigger? So 0.054 divided by 4, because it's quarterly. We're going to raise this up to an exponent of, let's see, quarterly is 4 times a year, 20 years, so 4 times 20, right? So let's see what this equals to. Ooh. Can we do this over here? Let's try it. I don't know if we can copy that and paste it. Yeah, we can. So can we do fraction stuff here? Oh, I could just hit divided. Oh, look at that. Now, quarterly, yeah, that's correct. Or we get an exponent. Yes. Plug in 80, right? Plug in 80 right there. So there we have it. 26,311. Plug that in. 26,311.33. Now if we hit the X button, it will put it in there for us. Alright, next question. On the monthly interest payment. Alright, Hilton Incorporated borrowed $80,000 for 7 years at a simple interest rate of 4.5%. The interest was to be paid monthly. So they're borrowing $80,000, find the monthly interest payment. Alright, look, for the monthly interest payment, we're just going to multiply this times the interest rate, the yearly interest rate, divided by 12. That's 1 month. We'll just do simple interest on $80,000 for 1 month. Let's try it. I'm going to go to math type, go to inline. I'm going to put, what are we looking for? How much interest? So interest equals to ERT, which is equal to 80,000 times the rate, 0.045, times the time, 1 over 12. The time is really 1 month. It's the same. Find the monthly interest payment. Okay, so we're just going to divide that by 12. We're going to plug it in over here, 80,000 times 0.045 divided by 12. I like the comma, so let me try it again. 80,000 times 0.045 divided by 12. That should work. 300. So this equals to 300. That's X to close this off. There it is. Took a little while to get in. See what's the total amount of interest paid. Notice that this is simple interest, so that's why we're using the simple interest formula. For the next one, we can just do it for the duration of the loan instead of dividing by 12. We can do it the following way. Let's see if I can copy this. Control C. P is the principal, R is the rate in years, and T is the time in years. So I can just change this to 7. See what I get. Getting Control C, copy this here, multiply it times 7. Get 25,200. Put that in here. 25,200. Press X to insert it. Press yes. There you go. Alright, so in 1 month you're going to pay $300, and in 7 years you're going to pay $25,200. Alright, number 3, a store has an interest rate of 1.5% per month. Unpaid balance of charged accounts. A customer charges $2,400 but allows it to become 6 months overdue. What is the bill at that time? Round your final answer to 2 decimal places. So what's going on here? We got a 1.5% per month. How long do we have it? 6 months. So this looks like we're going, what is the bill? So we need the future value of compound interest. Is it compound interest? Yeah, it's 1.5% per month. So let's see how we do this. Okay, so we're going to go to math type. We're going to go to inline. We're going to plug in the future value of compound interest, which is A equals to P1 plus I raised to the N. So we get an exponent like this. With an N here. Formulas are going to get more complicated, so watch out for the next coming example. So this is going to be equal to 2,400 times 1 plus 0.015. Alright, everything here is in months now, not years. So that's why we're using 6 and 0.015. So we're going to say that this is equal to, over here to our Desmos. Plug in here, we can say 2,400, 1 plus 0.015 raised to the 6. Press enter. I'm getting 2,624.26. Alright, press the X button, insert it, and that throws it in there for you. Give it a little time. There it is. Okay, there you have it. Number 4. The Citizens Bank sets up a scholarship fund by making deposits of $650 every 6 months at 12% interest. Find the amount of the annuity at the end of 9 years. Round your answer to 2 decimal places. Okay, these are recurring payments. We're making deposits every 6 months. We have the interest rate. Looks like it's either an annuity or amortization. What are we doing here? Scholarship funds. Seems like we're trying to grow wealth, so that's an annuity. Alright, we got it. It's an annuity. Go to math type. Inline. What are we going to do? For annuities, we have a future value of an annuity. A equals to R. You throw in some brackets. Put a fraction, throw in something like 1 plus I raised to the N. Reminding you guys of the formula and how to use math type. This is N, and that minus 1 divided by I. So that's the formula. So we're going to go right, equals, with the recurring payment, $650. I can copy this, Control C, Control V, come in here, change it. It's the periodic interest rate. It's 12%, but you're dividing that by 2 because it's every 6 months. So the compounding period is twice a year. So it's actually 0.06. In the numerator, we're going to put twice it. So it's twice a year because it's every 6 months for 9 years. So that's 18. Down here, we'll put 0.06. Say 0.06, and that's it. Come over here, equals, go to Desmos, plug it in. We'll plug in 650. See how Desmos does at this. I lost the fractions. Go to main. There we go, fraction. And in the numerator, we'll put a parentheses 1. Let's say 1.06. Actually, I didn't need those parentheses. Raised to the 18. Delete 18. Minus 1. We'll go to the right. Then minus 1. Wow, Desmos is really nice. 0.06. Okay. Enter. Okay, here we got the answer right here. I wonder if it'll let me copy it. Probably not. Control C. Come over here, Control V. Hey, look at that. Hey, let me copy it. Put a comma, press the X, enter it, we're off. Okay, we'll go click here, there it is. Number 5. How much is currently in an account that makes 9% yearly compounded semi-annually if we are withdrawing $12.50 every 6 months and empty the account after 5 years? Okay, what's going on here? We're withdrawing $12.50 every 6 months, so that looks like a recurring payment for sure. It looks like we are, how much is currently in an account that makes 9% compounded semi-annually if we're withdrawing So we're taking money out, we're not putting money in. That would be an amortization because the account empties. We're amortizing the amount. Think of it as there's a big amount of money that we're taking out $12.50 every 6 months. So every 6 months we're taking out $12.50, so we're decreasing the balance. There's like a balance, and we're making it smaller and smaller and smaller until we empty the account. So this is amortization. So we'll kind of steal this, copy, paste. But what are we looking for? So this is in amortization. We call this P, the amount borrowed. Everything's kind of the same. If I cut that and somehow insert it, minus, paste, get rid of that, put a negative here in front of the N somehow. There we go. And that's our formula. So I can now get rid of this inside. Delete, copy, paste, get rid of the 650. We now have new recurring payments of 1250. We'll put 0.06 here. Wait, why am I putting 0.06? And then 0.09. Let's see what's going on with this I. What's going on? 9% semi-annually. So I don't know. I'll teach you I kind of want you to get experience plugging in fraction within fractions. So 0.09 divided by 2 because it's semi-annually. Come in here, multiply. How many periods are there? Twice a year, semi-annually for 5 years. That's 10. Looks like 10 to me. Down here, we can put our fractions. So if I copy this, Control C, Control V, come over here and see what happens. See, I can't copy this. There's no way I'd be able to copy that into Desmos. I highly doubt that. Wishful thinking. Nope, didn't work. Okay, but I can copy this. Possibly. Control C, Control V, 1250. Move things around by actually changing this to plus and changing this to minus. And 1.1. Well, 0.09 divided by 2 is 0.045. So I'll just cheat. 1.0445 with a negative 10. Kind of cheating here. So what goes down here? 0.045. Alright, so that'll work. If I press enter here, it should give me the answer. Okay, where am I? I need to change this to 1250. The number looks a little bit small. 1250. Okay, so it looks like 9,000. Okay, well, we gotta round that. We'll change that to 90. Does this make any sense? Let's close this. Doesn't really make sense to me. Let's try to figure this out. How long is it? 5 years? Okay. 5 years, twice a year. It's only 10 payments of this amount. If I multiply this times 10, I get 12,500. And where's our answer? Must be down here. So it looks like, let me move this down so I can make sense of this. It looks like if we're pulling out 1250 every 6 months, so twice a year for 5 years, so 10 times, it's 12,500, and this is 9,000. Okay, this makes sense because we are gaining interest at 9%, so this should be less than 12,000. That's it. Number 6, on part A right here. A musician wanted to open a recording studio. He borrowed 50,000. Okay, borrowed might be amortization. The loan was at 4.9% for 7 years. The monthly payments were, I think we're missing a number here. It should be 704.35. Round your answer to 2 decimal places. How much of the first month's payment was interest? So for the first month's payments, we're just going to use a similar formula. I equals PRT, something like this. Control V. Was this? Wait a second. What was the total amount paid? It's like eerily familiar to this one. Total amount of interest paid. What's the difference? Total amount paid. Got it. Okay, these are different. How much of the first month's payment was interest and how much was principal? Okay, this is different. Different question then. Just double checking that. Alright, so look, you borrowed 50,000. I can change this to 50. 4.9% for 7 years. How much of the first month's payment was interest? Okay, so same thing here. Same idea here. I can change this to 4.9 divided by 12. Okay, alright, makes sense. Simple interest, first month's payment. How much was interest? Just, it's a simple interest, 1 month payment, interest. So let's plug it in. Where did I do something like that? Do like this. Copy, or just do this. Delete that, change this to 9. Change this to 5, and we get something. 50,000 times 0.049 over 12, we get an answer. Okay, we're about to change that to 7. Round that correctly, there we go, that's our answer. Insert that there. What was the total amount paid over 25 years? There's a couple ways to do this. Oh wait, principal. You'll see, we need the principal. I missed something. Principal is equal to payment minus the interest, right? It does that right now. It's kind of weird, but the payment was 704.35 minus the interest 204.17 equals. So let's see, 704.35 minus 204.17, getting 518. If I press the X button up here, boom, there we go. Cool, we got our, you know what, I don't know, I'm not too familiar with this, but let me see what I can do. Oh, format, style, text. Let's try text. Look at that. Yay. Press X. Yes. Looks a little bit better. Alright. What was the total amount paid over the 25 years? What we can do for that is, see, I always like copying things. Control C, Control V. Let's see. Okay, let's just say total equals to whatever we paid, which was 704.35 times. We're multiplying times 12. Are we paying monthly? I think so. Times how many years is it? 25. This, you know what? The times you should probably use these times. This time's actually better. 12 and the right is better to use. Control C, Control V. 25. Press equals X. Actually, let's get the value, huh? 704. Control C, Control V. Times 12 times what? 25. There we have it. That's a big amount. Control C, Control V, comma. So it looks like we're getting, you know, I kind of like, why am I not putting these in? Can I? Put a dollar sign. Okay, what's that saying? Cannot, maybe it doesn't work. We'll see. But 211,000, there you go. Press yes. Okay. If you want to change the size of these things, you always can. I'm going to press back. If you wanted to, you can do that. Okay, are we done almost? Last question. Let's see what's going on here. A married couple has a kid and wants to be able to pay for the kid's college. How much should be deposited on each of the child's first 18 birthdays to be able to withdraw $40,000 on each of the next 4 birthdays? Okay, this is a tough question, so we're gonna try to think through this one. Well, we need to pay, we want to withdraw $40,000 on the next 4 birthdays. That's amortization because we're withdrawing it until it reaches 0 in 4 birthdays. So we want to withdraw $40,000 for 4 years until we have nothing left. So that's amortization. Where is amortization? We need a negative n for amortization. So let me grab this. Actually, let me just press Control C, come down here. First, amortization. Control V, come in here. Let's get in there and see what's going on. What do we got? 40,000? What's happening? We want to, wow, we want to pay 40,000. That's a lot of money. We want to withdraw 40,000 for 4 years. It's annually, so this is just going to be 4. What's the interest rates? 9%, and that's annually. Okay, look, we got 9% again. Go here, just put 0.09, 0.09. Okay, that looks good. Delete this. Come in here. Let's say, where did we have an amortization? We had one like right here. Man, this Desmos is nice. 40, 1, 2, 3. Sorry, this is backwards, but 1.09, negative 4, 0.09. Man, I love this Desmos thing. Never used it that this much, but Control C, I'm usually using a calculator. I'm gonna make this 80. Okay, what do we got here? Does this make sense? So we need to have 129,000 in order to pull out 40,000 for 4 years. Notice that 40 times 4 is 160,000, but we are gaining interest. So we only need 129,000 in order to pull out 160. Notice that we're making what? A lot of money. 130 to 160. We're gaining like $30,000 on this because of the interest. All right, so let's see. I'm going to press X. Yes. From here. So we need, think about it. How much should be deposited on each of the child's first 18 birthdays? So for that, I'm going to say now annuity, recurring payments, 18 years. So I'm going to say, all right, let me get an annuity formula. Where's an annuity? This one has a positive N, so I'm going to grab this. That's an annuity. Control C, come down here, Control V, and I'm going to think about this. What's going on? Well, we need a different formula. This is where it's solving for the future value, but we need to find R here, so I can't use this. Let me close this out. But I might keep it up for a second. Kind of use the formula, so I need to create a new formula here. So inline, it should be R equals to an annuity. It has a future value, right? So annuities have future value, so AI, so what is it, 1 plus I raised to the n, then minus 1. There you go, that's our new formula. This equals to, we'll do something like this, copy, paste, come in here. What do we want? We want 129,588.8, and then for the I, change this to, what is it, 9%, 0.09. Then down here, what's going on? 1 plus, I'm going to call this 1.09. And over here, how many years is this? 18 years, because it's annually. There we have it. That's our formula. Do we have an annuity formula over here? I think we do somewhere. That looks like one. We'll say, but wait, this is not, oh yeah, I forgot we don't have this formula yet. So I have to create one. Let's see, can I delete that? Fraction 129,588.8 times 0.09 divided by 1.0. These parentheses are useless or unnecessary. So raised to 18, and then I'm going to say minus 1. Okay, look what we have here. We got to copy that. Say equals, paste that in, put a comma, dollar amount. Let's see if this makes any sense. I'm going to X this out, and then when I X this, it's going to put it in. So let's see if this makes any sense. We're done. So I'm going to get rid of this guy. What does it say? Annuity. Okay, does this make sense? I need to contribute $3,000 a year? Dang, $3,000 a year for 18 years. That's 18. What is that? 30, 24. It's only 54. Man, we're making a lot of money. Look at this. 9%. We're making a lot of money. We're gonna grow to 129,000. Is that even real? Does that even work? Let's try that. Telling me if we put $3,000 in for 18 years at 9%, we're gonna have 120. Look at, first of all, 3,137.64 times 18 is something that I can't get. Hold on, no comments here. Desmos doesn't like it. Look, $56,000, right? Now look at how awesome this is. This is amazing. $56,000, right? Look at all the money that we gained on interest. What is that amount? 129,000? 129,588.80 minus. This is I'm seriously thinking about investing now. Look at this. 129. Forget making these videos. Look at this amount of interest. 56,477. We just made $73,000. My goodness. We only put in $56,000 and we made $73,000 on interest. Jeez. We gotta start investing. And to double check things, if we put this recurring payment into an annuity, we can see if it gains this. Let's try that. Where's an annuity formula? Right. Okay, I'm gonna show you guys something cool. If I put in 3,000, where's 3,000? If I put in that amount, Control C as my recurring payment on an annuity, let me say times the annuity formula. It's 1.09 raised to the, we got 18 years. If I subtract 1 and put 0.09 here, look at that, look at that. Our $3,000, plug it into an annuity formula, look at it. It has a future value of 129,588. We verified that that's true. All right, so that is how you use my math lab, Desmos, and MathType.